Okay, so in this lesson, we're going to start talking about the introduction to polynomials, and this will be part one. And so let's look at a couple of terms, which is a review from a previous lesson. And the terms we're going to look at are the word terms and coefficient. Okay, so remember that a term is a number or a product of a number and variables raised to powers. And then note that the terms of an expression are separated by plus signs. So for example, for each expression, list the terms. All right, so we have this expression, 6x to the fifth plus 2x to the third plus 7x. And in this expression, you want to list the terms. Now remember, a term is a number, or it could be a product of a number and variables raised to a power. All right, so it could be a number or a product of a number and variables raised to a power. So for example, and remember that terms of an expression are separated by the addition symbol, the plus signs. So if you look at this expression, you have 6x to the fifth plus 2x cubed plus 7x. So in this expression, the terms would be 6x to the fifth, because remember the definition, one of the definitions of the term is a product. Remember, this means 6 times x to the fifth. So a product of a variable, a number rather, and a variable raised to a power. All right, so that's a term. And remember, terms are separated by plus symbols, by the addition symbol. The other term would be a positive 2x cubed, a number times a variable raised to powers. And it could be more than one variable. And then the other term would be 7x, a number, times a variable raised to power. Remember, there's no power there. It's understood to be a 1. So when you list them, and on the assignment, it's going to say there are more blanks than terms. So when you list them, though, make sure in each blank you put the term. So the first one is 6x to the fifth, the second one is 2x cubed, and then the third one is 7x, and you just leave the others blank. Okay. Part B. All right, now notice that when we did part A, all of the terms were positive. A positive 6x to the fifth, a positive 2x cubed, and a positive 7x, because that's what it was. A positive 6x to the fifth plus a positive 2x cubed plus a positive 7x. But when you get to this one, you'll notice that in this expression, the terms are 8x to the sixth, so a number times a variable raised to a power. Now, remember, in this note right here, we did state that terms of an expression are separated by plus symbols, by the addition symbol. But when you look at this, you might say, well, that's not an addition symbol, that's a subtraction symbol. So the mistake people make is that when they list the terms, they want to say that this term is a 5x, and it's not a positive 5x. So you got to recall that 7 subtract 8, so whenever you have a subtraction symbol, you can always rewrite it as an addition symbol. So that's 7 plus, an addition problem, so that's 7 plus, and then the opposite of a positive 8 is a negative 8. All right, so then you wrote this as an addition problem as a plus symbol. So when you look at this one, the way you want to think about this is this. So this is going to be, now in your mind you would do this. You don't necessarily have to write what I'm about to write, but you would say, well, that's going to be 8x to the 6th, and then when I subtract a 5x, that's the same thing as adding the opposite, so adding a negative 5x, and then plus 2, that's already an addition symbol. So now you should be able to look at this and determine the terms. So the terms are a positive 8x to the 6th, a negative 5x, and a positive 2. So those are your terms. So when you list your terms, and remember we're going to have more blanks than are needed. You just write in each blank each term. So you have 8x to the 6th, negative 5x, and a positive 2. All right, the next one. All right, same idea in the next one. So if you need to rewrite it, just rewrite it. So this is a negative x to the 8th plus a negative 7x squared plus 2/3 x cubed. So again, you're subtracting. So if you need to, you don't have to rewrite it, but if you need to, just remember that change this in addition problem. So that's plus a negative 5x and then plus 2. So now you can list your terms. So again, in each blank, you can put the terms. So the first one that's listed is a negative 3x to the 8. So don't forget, if the term is negative, you got to list the negative symbol. The next term is a negative 7x squared, not a positive 7x squared, so you got to be careful. So remember, subtracting a positive 7x squared means adding a negative 7x squared. The next term is 2/3 x cubed. The next term is a negative 5x, and the next term is a positive 2. All right, so that was example 1. So in example 1, you had to first of all know the definition of a term, and you had to know that terms are separated by the addition symbol. And whenever you have a subtraction symbol, you need to change it to an addition symbol. All right, and then you just list the terms. So some terms are positive, some terms are negative. Okay, now let's look at the next part. Okay, so the other part that we wanted to look at, so we looked at the word term. Now let's remember what a coefficient is. So a coefficient, and another word for coefficient is numerical coefficient. They mean the same thing. When we talk about coefficient, we were talking about the numerical coefficient. So the numerical coefficient of a term is the numerical factor of each term. So it's whatever the variable is being multiplied by. So remember, factor, when you look at the word factor, you think of multiplication. So the coefficient of a term is the numerical factor of a term. So note that if no numerical factor appears, if you don't see it in the term, then it's understood to be a 1. So if you don't see it, it's understood to be a 1. So you can look at some examples. Also, keep in mind, and we're going to look at this as well, that if a term is a number only, meaning there's no variable associated with it, there's no variables in it, it's just a number, then it's called a constant term, or simply a constant. All right, so keep those notes in mind. All right, so here we go. So in example 2, for each term, you want to list a coefficient. So remember, the definition of coefficient, same thing as numerical coefficient, is the number that you're multiplying the variable by, the numerical factor, the number. So in 5x to the 4th, the numerical, the coefficient would be 5. In negative 2x cubed y, whatever you multiply the variables by, well, multiplying the variables by negative 2. So negative 2 times x cubed times y. So the numerical coefficient, or the coefficient, is a negative 2. All right, now here, remember, that's one of our notes. So if you don't see a number, a numerical factor here, remember that's understood to be a 1. So 1 times x to the 5th. So you'd say a 1. All right, now over here, let's go back to C. So this is a positive 1. Over here, would be considered a negative 1. So if you need to, if you need to think about it that way, think about it that way. So that's a negative 1. E, same thing. Consider that like a negative 1x. Negative 1. That's a coefficient. So the coefficient is negative 1. All right, now F, see, that's the other note right here. So if there's if the term is a number only, then it's considered to be a constant term, or simply a constant. So in letter F, since there's no variable associated with it, this is called a constant term. And so that's going to be an important word for you as you go through your courses. So constant term. And so the constant term, the numerical coefficient, would be that number. So you would say 4. Don't leave it blank. We still, even though it's a constant term, we still say that the numerical coefficient is 4. Okay? Still say it's 4. All right, now let's look at the next one. Okay, so let's talk about polynomials now. The polynomials. All right, so at first, when we talk about polynomials, we're going to be looking at a polynomial in just one variable. So the only variable you're going to see is x. All right, and so a polynomial in x, so whenever you look at a polynomial that has just the variable x in it, and you can see what I'm talking about as we go to it, is a finite sum. So finite means that you can count them. It's not infinite. Finite means you can count. So like 3 terms, 4 terms, 5 terms, 6 terms, 7 terms, 8 terms, and so on. And it has this form. So it's some number times a variable raised to a power. So each term is finite set of terms, and each term is some number times a variable raised to a power. So it's kind of like we just did. So if you look at part example 2, see all these would be terms. So all these would be part of a polynomial. Those would be terms of a polynomial. Now here's important though. This number, this numerical coefficient, this number right here, is a real number. So it's going to be any real number. It could be a decimal, it could be a rational number, it could be an irrational number, it could be an integer, any integer, and so on. Okay, but in your exponent, the exponent is important. The exponent must be a whole number. Okay, so it must be a whole number. It cannot be a decimal, it cannot be a fraction, it must be a whole number. Another thing is that it cannot be negative. Okay, so let's talk about what a whole number is. So let's remember what a whole number is. So a whole number, let's talk about what whole numbers are. So here's your whole numbers, your set of whole numbers. So the first whole number, the smallest whole number is 0. That's your smallest whole number. So this can be a 0, x is 0. The next one is 1, then 2, 3, 4, 5, 6, and so on. So those are your whole numbers. So your whole numbers are 0, and then on your finger you can count them. 1, 2, 3, 4, and so on. Okay? No decimals, no fractions, none of them are negative. Okay, no negatives. Alright, so that's going to be important when we talk about polynomials. Okay, so remember that about whole numbers. So your smallest whole number is 0, and then you start counting with your fingers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and so on. Okay? Alright, so let's look at example 3. So determine whether the expression represents a polynomial or not. And then in the blank you just write yes or no. Alright, so remember a polynomial is a finite set of terms. And the important fact is that your exponent must be a whole number. That's going to be important to remember. So let's go to the first one. So we have this expression. There are, let's first of all count the terms. There's 1, 2, 3, 4. And so really all you need to look at is the fact that is the exponent a whole number. So look at this first term. The exponent is 3. That's a whole number. The second term, the exponent is 2. The exponent of the variable. That's a whole number. The next term, the third term, the exponent is 1. There's no variable there. I'm sorry, there's no exponent there, so it's to be a 1. And then the next term is a constant. All right, so now I want to talk about something about this constant. So let's remember this thing about this constant. All right, so we have, I'll go ahead and write it here. So let's talk about a constant. So the constant 5. So remember in a previous lesson, when we talked about exponent, the 0 exponent rule. Now remember the 0 exponent rule stated that if you have a non-zero number raised to the 0 power, that's equal to 1. Okay? So any non-zero number raised to a power is equal to 1. So that was in a previous lesson. So when we look at this 5 right here, that's constant. So I want you to note that 5, the constant 5, is the same thing as saying 5 times x to the 0 power. See how this term has an x in it, this term has the variable x in it, this term has a variable x in it. You might say, well, there's no variable x in here. Well, you don't see it. That's why it's called a constant term, but you can write it as 5 times x to the 0 power. And these two are equal. These two are equal because, remember, x to the 0 is 1, and 1 times 5 is 5. And so now look at this right here. So this exponent is 3, that's a whole number. This exponent is 2, that's a whole number. This exponent is 1, that's a whole number. Remember, your constant the one that doesn't have a variable in it, you don't see a variable associated with it, that constant has exponent 0 for the variable. And that's a whole number. 0 is a whole number. Okay, so the question then becomes, is this a polynomial? The answer is yes. So you write the word yes, because all of these exponents are whole numbers. Okay, so remember, a constant satisfies the definition of a polynomial. So a constant is a term of a polynomial. So you see this 5? It will be 5 times x to the 0 power. It's important to remember. This right here is 5 times x to the 0 power. So each term must look like this. Okay? All right, part B. All right. Now, although this polynomial has other variables in it, that's okay. Let's just look at the exponents. All right. So here, when we define polynomial, we're talking about a polynomial with just one variable in it, the variable x. In another part of this lesson, and in the other lesson, the next lesson or so, you're going to have more than one variable, which is what this is. All right, but it's okay. We can still talk about, is this a polynomial? So a polynomial, a term can have more than one variable in it. All you got to do, though, is just look at the exponents and just make sure that these are real numbers. And they're all going to be real numbers in this course, and then the next course as well. So just look at the exponents. That's a whole number. 1's a whole number. 3's a whole number. And if you look at this term here, this third term, remember there's no variable there, so it's to be a 1. That's a 1. That's a whole number. 1 is a whole number, so you say yes, that's a polynomial. All right, let's look at the next one. So again, you want to determine, is this expression a polynomial? Well, again, just look at the exponent. So 5 is a whole number. The issue is -4. -4 is not a whole number. Remember, your whole numbers, the smallest whole number is 0, and then 1, 2, 3, 4. None of them are negative. Whole numbers are not negative. They're not decimals, they're not fractions. They're just whole numbers, including 0. 0 is the smallest. So the issue is -4. All the others are fine. That's a whole number, 3 is a whole number, and then 7x to the 0, 7x to the 0, and 0 is a whole number. But the issue is this. So this is no, because, let me write this up, because the second term has a negative exponent. Okay, second term has a negative exponent. All right, now if you look at letter D, is that a polynomial? So you have -3x cubed plus 7x to the 4.7 power, and then minus 3x. All right, so is 3 a whole number? The answer is yes. Is this 1 a whole number right here? The answer is yes. Is 4.7 a whole number? The answer is no. So is this a polynomial? The answer is no. No, since, again, the second term, the exponent is not a whole number. Okay. All right. Now let's talk about, this is going to be important at some point, especially when you start factoring in the next course. So when you factor polynomials, and that's going to be in the next course, when you factor polynomials, you're going to want to put those polynomials in descending order. So let's talk about what we mean by descending order. So a polynomial is written in descending order. Remember, descend, if you're in a flying in a plane and you descend, your elevation decreases. So you're getting closer and closer to ground level. So it's decreasing. So a polynomial is written in descending order. Again, we're going to be talking about one variable. In this case, we're going to write them as variable x. If the power decreases from left to right. So as you write it, you're going from larger exponent to smaller exponent. Okay? All right. So let's look at example 4. So in example 4, you want to write each polynomial in descending order. Okay, the first one. You have this polynomial. 3x squared plus 5x cubed plus 3 plus 5x. Remember, this is a polynomial because if you look at the exponents, they're all whole numbers. 2, 3, this is a 1, and the constant, remember the constant that has an exponent 0 for the variable x. So remember, 3 is equal to the same thing as 3x to the 0 power. So that's a whole number. All right, so you want to go from largest exponent to smallest. So if you look at each of those terms, and there are 4 terms, positive 3x squared, positive 5x cubed, a positive 3, that's your constant term, and then a positive 5x. So you want to list the one with the larger exponent first. The larger exponent is 5x cubed, so you put that first. Okay, then the next one is a positive 3x squared. So you can say plus 3x squared. Okay, so you got to use the addition or subtraction symbols between them. Then the next one is, so you're going from 3 to, so you see how it's decreasing, the exponents are decreasing, so you go from 3, 2, and then the next one, there are only 2 left. So this has exponent 1, this has exponent 0, remember exponent 0 here. So you're going to say plus 5x, and then plus 3. And I want you to notice as you go through this, your constant term is always listed last. The constant is always listed last. So notice the first 3 terms, you see the variable x, and then your constant term is listed last. And so just make sure it's a decreasing order. That's going to be important in the next course as well. 3, 2, 1, and then 0. X is 0. Got the next one? All right, so remember in letter A, we had all positive terms. So remember letter B, you'll see that we have a negative term now. All right, so this is a 2, this exponent is a 1, this exponent is a 3, and then this would be 6x to the 0 power, so that will be a 0. So you list the larger one first. The larger one is a positive 3x cubed, so a positive 3x cubed. Then the next one is a positive 7x squared, so plus 7x squared. Then negative 4x. Don't forget your sign. It's important to remember that the term here is not 4x, but a negative 4x. And then your constant is always listed last. And so notice that this is in descending order. 3, 2, 1, 0, x to the 0. Don't forget to keep the sign. So that's a negative 4x. Don't say that's a plus 4x. Say minus 4x. Okay, next one. So here you have 3 terms. The first one's a negative 3x to the first. The next one is a negative 2x to the fourth. And then the next one is a positive 5x squared. I want you to notice, though, there's no constant term in this one. There's no constant term. So this polynomial, and these are polynomials because the exponents are whole numbers. There are no constant term, though, but we still write in descending order. So the largest exponent is 4. So we're going to say negative 2x to the fourth. So notice I said negative 2x to the fourth, not a positive 2x to the fourth, negative 2x to the fourth. The next one is a positive 5x squared. And the next term, this has exponent 1, so we say minus 3x. So notice I wrote in descending order. This term, the exponent is 4. This term, the exponent is 2. And in this term, your exponent is 1. All right, now, this is going to be important as well when you, especially next semester when you start factoring, because determining the type of polynomial can help you to determine how to factor it. And then also we're talking about GCF. And so that will be a monomial factor that you would factor out. So we need to talk about types of polynomials. So as we go through this, just remember that there are going to be 3 types of polynomials. We have a polynomial that could be called a monomial, mono meaning 1. And so it's a polynomial with exactly 1 term. So monomial, 1 term, mono, 1. The next one is a binomial. Binomial, bi meaning 2, like a bicycle, 2 wheels. So a binomial is a polynomial with exactly 2 terms. And then a trinomial, like a tricycle, 3 wheels, is a polynomial with exactly 3 terms. And so those are the 3 special names that we give for certain polynomials. Now remember, a polynomial can have more than 3 terms. All right, but these are the names we give the 3 of them. So a monomial is one polynomial, 1 term. A binomial is a polynomial with 2 terms. And then a trinomial is a polynomial with 3 terms. A polynomial that has more than 3 terms, we don't have a special name for it. These are the three special names because they occur more often. These types of polynomials occur more often in the types of situations that you're going to be involved with in your courses. All right, look at example 5. So in example 5, you're going to be given some polynomials, and you want to determine whether it's a monomial, a binomial, or a trinomial. And remember, those are the three special names. Anything more than 3 terms, it doesn't have a special name. We're just going to say none of these. You're going to write the words none of these. Okay? All right, so look at this one, letter A. So we have this polynomial. The question is, how many terms do you have? That's all you have to look at. Well, there are 2 terms. The first one's a 6x, and the second one's a -2. Remember, -2 is your constant. So there are 2 terms, so this will be called a binomial. All right, don't abbreviate. Make sure you write it out. Okay, the next one is, when you read it, this is 5x. That's 1 term, 5x. That's a monomial. Okay, 1 term, monomial. The next one, all right, so if you look at this one, we have a -5x cubed, so that's 1 term. We have a +7x, so that's number 2. And we have a -5, so that's number 3. Remember, -5 is called your constant since it doesn't have a variable. So there are 3 terms here. So that's called a trinomial. All right, and then finally, your constant. So just like letter B, see how you had that 5x, 1 term? That's a monomial. And then a constant, 1 term, that's also a monomial. So you'd write the word monomial. All right, E. So if you look at this, that's determine how many terms. Well, 2x squared is 1 term. -6x is another term. So there are 2 terms. So binomial. And then letter F, you have 7x is 1 term. +2x squared is the second term. A -6x cubed is the third term. And then a +2 is the fourth term. Now remember, so this polynomial has 4 terms. Is there a special name for a polynomial with 4 or more terms? The answer is no. So you're just going to say it's none of these. It's still a polynomial, but we don't have a special name. So we're just going to say none of these, meaning that it's not it's not a monomial, it's not a binomial, and it's not a trinomial. It's just none of these. It doesn't have a special name. Okay, so that's going to take care of this lesson. So you should be able to do the assignment that pertains to this lesson.